Welcome to The Explainer. Today, we're diving into a massive, absolute game changer in how software is built, prompt engineering for coding and development. Listen, my core thesis for you today is super simple, but literally transformative. Better prompts equals better code and way faster development. We're going to flip the script on how you talk to AI, turning you from, a casual user into an absolute power user. There's this fantastic quote that hits the nail on the head right out of the gate. AI doesn't replace developers. Developers who write better prompts build faster. And honestly, that's exactly why we're here today. Think of me as your personal coach for this session. We aren't just going to talk about casually asking an AI for a snippet of code. No, we're going to engineer instructions so incredibly precise that your AI coding assistant will practically read your mind. So here's our blueprint for today's masterclass. We'll kick things off with the AI coding assistant, move right into the perfect prompt formula, and then apply it to generating and documenting code. After that, we'll tackle debugging and self-repair, and finally, we'll unlock some advanced techniques like Scott and React. All right, let's jump right into section 1, the AI coding assistant, going from basic boilerplate all the way to building full apps. Okay, moving right along to section 2, the perfect prompt formula. Listen, this right here is the foundational blueprint you absolutely need for talking to any AI coding model. So there are 5 core pillars of professional developer prompting. First up, role. You've got to give the AI an identity, like you are a senior backend engineer, just to set that technical tone. Second is context. Tell it your environment, your language, the frameworks you're using. Third, requirements. What exactly does the AI need to do? What input is it working with? Fourth are your constraints. These are your hard rules. Think readability standards, performance limits, or maybe specific libraries you absolutely don't want it to use. And fifth, output format. Do you want a raw code block, JSON, a step-by-step tutorial? Look, if you skip these 5 things, the AI is just going to guess. And honestly, that is exactly when you end up with completely unusable code. That brings us to section 3, generating and documenting code. Now, before we look at a genuinely great prompt, we've got to ask a question that I'm sure we've all felt some serious frustration over. Why do basic prompts fail so often? I mean, if you just type /add auth or make a search function, you are giving it incredibly vague instructions. The AI has no local hints, right? It doesn't know your target framework. It definitely doesn't know your security standards. And vague prompts, well, they lead to brittle, messy code that you're going to spend more time fixing than if you just wrote the whole shebang yourself from scratch. Let's do a quick before and after makeover to really see this in action. Take a look at the left side here. It's a decent start, right? It gives a role and a basic requirement. But over on the right, man, we level it up. We specifically say Python 3. We add clear, hard constraints like handles invalid URLs and saves images locally. We even define the output format by telling it to explain the execution flow. By slapping down these explicit guardrails, we make sure the AI aligns perfectly with our standards. No more guessing, just straight up execution. And the really cool thing here, this formula adapts to absolutely anything. Let's say your goal is documentation. Well, you just prompt the AI for beginner-friendly READMEs or setup guides. Working with APIs, prompt it to break down the endpoints, the authentication, and ask for integration examples. Or maybe you're refactoring. You just feed it your legacy code and constrain the AI to improve readability and strip out duplication, but, and this is key, without changing the actual behavior. It's literally the exact same 5-pillar formula, just pointed at different developer targets. All right, let's shift gears into section 4, debugging and self-repair. So when your code inevitably breaks, you need a highly specific debugging formula. Here's what you do. You provide the problem, the exact error message, the code itself, and the expected result. And here is a massive pro tip for you. Always, always include your exact environment. Like if your JavaScript fetch request is returning undefined, don't just ask the AI to spit out the fixed code. Explicitly ask it to explain the root cause. Ask why it happened. That way you're actually learning from the interaction instead of just copy-pasting. Now, this brings us to a super fascinating, almost surprising discovery about how well AI can actually debug its own code. It turns out AI is remarkably good at fixing its own syntax and timeout errors. We're talking hitting over 90%, sometimes even 100% success rates in benchmark tests. It's incredibly reliable there. But assertion errors, those tricky logical mistakes where the code actually runs but gives you totally wrong output, those are way harder to crack. The AI repairs those only about 45% of the time, mainly because fixing those requires a deep reevaluation of the underlying logic, not just catching a simple typo. And check this out. The timeline for success is totally skewed toward the very beginning. The vast majority of an AI's self-repair success happens in the very first round of feedback. If it fails on the first try, feeding that error right back in for round one yields huge immediate gains. So the big takeaway here, never give up after just one failed attempt. Feed the error back once, maybe twice, but, if it's still failing after 3 rounds, yeah, you probably just need to scrap it and rewrite your prompt from scratch. Which leads us to our final stop, Section 5, Advanced Techniques, specifically Scott and React. Okay, you've probably heard of chain of thought prompting, right? Where the AI sort of thinks out loud, step by step in natural language. Well, for coding, we use something called SCOT, structured chain of thought. Instead of letting the AI ramble in human sentences, we force it to build intermediate reasoning steps using strict program structures, things like sequences, branches, and loops, along with really explicit input-output formats. Basically, we are forcing the AI to literally think in code logic before it writes a single line of the final script. And the research data absolutely backs up why we do this. Using structured chain of thought drastically improves first-try accuracy. In benchmarks like human eval, Scott prompting outperformed standard methods by up to 13.79%. It's huge. It reduces ambiguity, leads to way less code smell, and results in highly readable, maintainable programs. Why? Because the AI actually planned out the architecture programmatically before it started typing syntax. Building on that programmatic thinking, we have the React loop. That stands for reasoning plus acting. This is really the core pattern behind modern AI agents. Instead of just generating a single shot, cross your fingers, guess, an agent using a React loop actually alternates between internal reasoning and taking real external actions, like querying a live database, searching the web, or actually running a Python script, all to complete a complex task. Let's break down how this creates a continuous cycle. It operates in 3 distinct phases. First is thought. The agent stops and thinks, okay, what do I know and what do I still need? Second is action. It calls a specific tool or function, like executing a web search. Third is observation. It analyzes the result of that action. If there's an error, it observes it, reasons about it in a brand new thought phase, and takes a new action. Guys, this loop right here, this is exactly how complex AIOps and multi-agent workflows are being built today. It's the secret sauce that makes AI truly autonomous. So here is my coaching call to action for you today. I challenge you to try a practical exercise the minute we're done here. Take that 5-pillar formula, role, context, requirements, constraints, and output format, and apply it to whatever project you're working on right now. Use it to build a responsive HTML landing page or write a Python file automation script. Try using it to debug a tricky JavaScript error or fetch data from an API. Honestly, just try it and see the difference for yourself. I want to leave you with a provocative thought to wrap up our explainer. As these AI agents fully master the React loop, and as they inch closer and closer to perfect self-repair accuracy, what exactly is your future as a developer? Will your primary role remain just typing out the code? Or will you evolve into the architect, the one engineering the master prompts that actually build the software? Thank you so much for joining me to explore this incredible shift in development. Get out there, start engineering those prompts, and I will see you in the next explainer.